Okay, this is the book Prevent and Reverse Stroke and Heart Attack by me, Pete Rogers. We're on figure 424. If you're following along in the book, we're on page 112. So what I'm basically talking about here is how brain cells work. And I've talked about this previously. If you haven't seen it before, my lecture on membrane ion pumps, it's a really good one where I go through all the metaphors of understanding that extracellular space is always high in calcium and in sodium because it's just like seawater. Intracellular space is high in potassium and in magnesium, okay? When calcium comes in, it's the aristocrat ion. It just bosses everybody around. It's kind of like Big Mama. When Big Mama comes home, she just starts yelling at everybody. How come you didn't pick up the dishes? How come you didn't pick up the dog crap? I thought you were going to clean the garage today, okay? So calcium is the boss. And when it's elevated in the cytoplasm, it makes the cell do whatever the cell is specialized to do. For example, release its neurotransmitter in a brain cell, in a neuron. Okay, then the cell has to pump the calcium out. So I'm talking a little bit about how calcium gets into the cell. The main excitatory neurotransmitter in the brain, 90% of your neurotransmitters in your cerebral cortex are glutamate. So glutamate is the excitatory neurotransmitter. And then the one to shut things off, about 5% of your neurotransmitters, is GABA. And then all the other famous ones like dopamine, acetylcholine, norepinephrine, epinephrine, all that stuff's about 1%, okay? They get a lot more press, but glutamate's the big dog, okay? So first of all, it binds to the AMPA receptor, the glutamate, after it's come across the synaptic cleft, and lets sodium come into the cell. The sodium depolarizes the cell, makes it more positively charged. Once the cell becomes more positively charged, the magnesium that had been guarding the center of the calcium channel, the NMDA receptor, will pop out. And then now calcium can rush into the cell. Calcium goes up, the cell will be activated, okay? That's basically how you activate a neuron. And it's going to matter because I'm going to get into the concepts of supply and demand here in just a moment. So here is a more detailed slide. The glutamate comes across the synapse, activates AMPA receptor. That's a sodium channel. Sodium comes into the cell, raises the membrane potential from negative 65 to negative 40 millivolts. So it's becoming more positive, less polarized. And the word for that's depolarized. That will cause the magnesium, because now there's only a negative 40 millivolt charge inside the cell instead of negative 65. Its positive charge is then less attracted. The magnesium pops out, and now the calcium channel opens up and calcium floods into the cell. Under normal circumstances, that's how the neuron is supposed to work. But we're going to show you there's a bunch of things that can overactivate this calcium channel for glutamate. It's called the NMDA receptor. You'll sometimes hear it is called NMDAR, and R is just for receptor. Okay, and we're going to show you how if this gets overactivated and lets in too much calcium, that can cause problems in the postsynaptic neuron. Okay, here's Toxic Legacy. This is the book by Stephanie Seneff. It's a really good book about glyphosate, the weed killer that's in Roundup, and she wrote very extensively on this. She's got good lectures on it too with all her slides and stuff. And it's an excitotoxin. It does a lot of bad things. It increases the risk of leaky gut, a fatty liver, diabetes, and it also causes increased activation of the NMDA receptor in the brain, so it has an excitotoxin effect. Okay, just to show you too, cortisol, one of your main stress hormones, it will also cause increased glutamate in the hippocampus. It also causes your blood hyperlipidemia, so it causes insulin resistance, increased risk of diabetes. But it's a brain excitotoxin. It stimulates the brain. In the morning when you wake up, you get a little surge of cortisol, but that's okay. Get your blood glucose up a little bit, perks you up a little bit to wake up and get on with your day. That's normal. In stress situation, it goes way up to help you have energy in your blood, in the form of glucose and lipids to, do whatever you have to do to survive an acute stress event. But you don't want high cortisol around the clock. You want it to be down real low, especially when you're going to bed at night, you're sleeping. Things that will increase cortisol, psychological stress, and sleep deprivation, and caffeine. So you want to avoid all those things. They're all bad because they're going to hyperstimulate your brain cells. You don't want that. Okay, here's a little bit more detail on a neuron. You usually see them drawn as a bipartite synapse, and here I'm showing you a tripartite synapse, meaning 3 parts. So there's always going to be the presynaptic neuron that sends its neurotransmitter down into the cleft. The glutamate here is released from the presynaptic terminal vesicles, merges with the plasma membrane, glucose comes out, binds the receptor on the postsynaptic cell. Okay, then it activates the postsynaptic neuron. The glutamate then diffuses from the cleft laterally to the astrocyte supporting cell, kind of like the mama cells, and it will take up the glutamate, convert it into glutamine, then it can be sent out. You don't want to send glutamate back out or it could end up over here. So glutamine will come back out, gets recycled into the presynaptic neuron. Okay, that's a tripartite synapse. That's a common way to draw synapses. So again, glutamate is excitatory, activates the AMPA receptor, lets sodium in, depolarize the cell, and then the magnesium pops out of the NMDA receptor and calcium can enter the cell. That's real standard neurophysiology there. Now I'm going to show you other things that are happening. You can counter that effect if you increase the amount of GABA getting into the cell. GABA comes into the cell, it lets more chlorine come into the cell. The chloride then has a negative charge, so it repolarizes the cell, and it'll prevent the effect of the cell releasing its neurotransmitter. So it's an inhibitory neurotransmitter. It's like glutamate turns the light on, GABA shuts the light off. Okay, now here's showing you an example of what can happen with overstimulation. So if you overstimulate this NMDA receptor, let too much calcium come in, it can do a bunch of bad things. It can activate a calpain protease that damages, chops up cells, chops up tissue inside the cell, and the knockout exchanger, bad, bad, bad. By the way, aspartate can activate this receptor. Glyphosate, which is like glycine phosphate, can bind the glycine coincident detector component of the NMDA receptor and activate it. So the bottom line is that glyphosate is bad. It's bad for your brain, bad for your liver, bad for your gut, increases diabetes risk. You don't want it. That's why I say only eat organic. All this stuff wasn't that well known in the past, but tell me it's well known now. You want to avoid it. When you eat high-fat diets, you'll have to you cause insulin resistance, so you get more insulin in the blood, hyperinsulinemia. Then insulin-degrading enzyme in the peripheral of the body, the non-central nervous system part of the body, has to degrade that insulin. And they only make it in fixed amounts, so there's less available to then clear out the beta amyloid, because it also clears out beta amyloid protein from the periphery of your body. So when you can't clear out the beta amyloid protein, I usually abbreviate it BAP, beta amyloid protein, it'll recross the blood-brain barrier, come into the brain, and it will also activate the NMDA receptor and let too much calcium in. So it also is an excitotoxin. So that's part of the reason. It's one of the many reasons why diabetes patients are so stupid, because they got multiple things working against their brain. That's why even if they got diabetes and their blood sugar is good with their medication dosages, they're really being foolish to not try to cure it if possible by optimizing their weight with a low-fat vegan diet. EMF will also activate voltage-gated calcium channels. Like if you hold a cell phone next to your head or you sleep next to a Wi-Fi router, you don't want that. You get more calcium going into these cells. That can make you a little bit anxious, a little more irritable, a little more impulsive, a little more insomnia. Okay, let's see. I think I'm going to show you maybe about one more slide on this. Maybe two more. So here is a four-part synapse when you've also got a microglia cell adjacent to the synapse. And you don't want these to be overactivated. Like if you got a leaky blood-brain barrier, you can get bacterial endotoxins, LPS and LTA, causing this to be activated, and it's going to release chemicals that are going to be toxic to the synapse. We're not going to go into that too much right now. Here's also showing cortisol from psychological stress, caffeine, sleep deprivation, or cortisol medications can increase activation of this presynaptic neuron to release more neurotransmitter. You don't want that, okay? And the EMF can open up the voltage-gated calcium channel, okay? You don't want that. And this is just showing more of the damage that can happen if you get excessive calcium going into the cytoplasm. Excessive opening of the NMDA receptor can also activate something called neuronal nitric oxide synthase. That's not the same thing as endothelial. And in small amounts, it's normal, but when it's excessively activated, this abnormal excess amount of nitric oxide can travel from the cytoplasm into the mitochondria and produce peroxynitrite. You don't want that, because then you can activate the no pathway. So this will be the last slide for today, and the point of it just is there's a lot of things that are going to lead to increased cytoplasm calcium. Mitochondrial inhibitors will do it because you can't make the ATP to pump the calcium out of the cytoplasm. You always have to pump against a gradient, so you always need ATP to pump calcium out of the cytoplasm. I realize this lecture is a little complicated, But if you really want a deep understanding of neurophysiology, this is a lecture. For a superficial understanding, you don't have to have this. But for a deep understanding of excitotoxicity, of my supply and demand, neurodegeneration theory, it's good to know this. And it helps you understand why it's such a big deal to try to avoid mitochondria inhibitors, SERCA inhibitors, sarcoplasm, endoplasmic reticulum, calcium ATPase inhibitors. That prevents you from being able to pump the calcium from the cytoplasm into the endoplasmic reticulum. So that's bad. Pretty much whatever causes diabetes, whatever smells bad, tends to be a SERCA inhibitor. So if something smells bad, walk away. Like cleaning chemicals, walk away from them. They're bad for you. Okay, we talked about stress, sleep, and caffeine all increase in cytoplasm calcium. We talked about excitotoxins, MSG, manufactured free glutamate, so that's the stuff in processed food. Aspartame, the artificial sweetener, glyphosate on the non-organic foods. Stimulants will have this effect in general. Lack of dietary potassium and magnesium also leads to a trend towards increased cytoplasm calcium. That's bad. Excessive dietary sodium also, because it has a displacing effect on the potassium and magnesium, or hypoxia of the cell due to atherosclerosis, diabetes, and hypertension will contribute to this. So they're all bad. And the reason I'm going through all this, traumatic brain injury does something similar. And excessive VOCs, volatile organic chemicals, are often SERCA inhibitors as well. All of those things are contributing to this. So what I'm saying is, this is why I also say you want to be as healthy as possible. So you minimize all these things that are nickel and diming your brain cells, and you prevent your brain cells from going into apoptosis, programmed cell death. So you keep your smarts a lot longer for the rest of your life. All right, so that was the baseline on calcium neurophysiology. In my other lectures, I go into more detail, explain into more detail. In my lectures on my Food, Mood, and IQ book, I go into way more detail on it. But the main concepts were there, and I think the most useful thing is going to be watching my video on membrane ion pumps, because that explains how to think of calcium, potassium, sodium, and magnesium in a way that it'll make sense to you the rest of your life. So anyways, I hope you found that helpful.